All right, today what we're going to be talking about are graphing square root and cube root functions. So let's get into it. So when we're graphing square root functions, so for the first part, your parent function is going to be f of x or y equals x squared. This is considered the parent function. So when you do that, when you plug in your value for x, you're going to get the corresponding point, and then I just went through and I filled out the table already. And we're going to go ahead and we're going to plot it. So once you've got here, and if you notice, this is just the standard what we've done before. You plug in your points, and then you go over 1, up 3, and then we'd go over 1, up 5, and so we plot our points, and then we reflect it over to this side. So this is what we've done before. So now we're going to take what we know from this parent function, and we're going to take the square root of it. So now that we're taking the square root, you notice the parabola looks like this, but when we take the square root of it, it's turned on its side, and it looks like half of it, because if you notice here, again, I entered in the information, I entered in your x here, and we would have -4. Well, that would be I 2 root I. So then again, I just used a calculator for these. So for square root of -3, you'd get 1.73 I. -2, you got this. And -1, because we said -1 would be I. Now, once I go to 0, I'm going to get a positive number. And then same thing with 1. And then 2, I've got a decimal. 3, I've got a decimal, but it's all positive. And then once we have 4, our point is 2. So we're not going to graph the imaginary numbers because you can't graph them on the plane. So we are really ignoring all of those. So that's why there is not the other half. So we can't have the other half because we can't graph those. So this is really half your parabola is your square root function. So there's some key points here that we'll talk about in a second. And so the characteristic of a square root graph, this is your parent function for it. So you're going to go, you have your, it's called an anchor point instead of, think of it like your vertex, but it's called the anchor point. And that is where it begins. So your starting point. So in this case, for the parent function, your anchor point is going to be 0, 0. Now your increasing intervals are where it goes above the x-axis. So remember, you're looking at your x, so it's starting at 0, and it includes 0, and is going to infinity. So that's why we have that. So you're looking at your x value for this one. Domain, you're also looking at your x value. So again, it goes from 0 to infinity. And then range, you're going to look at your y value. So for your y, well, first off, oops, I skipped this one. Decreasing interval. There's no decreasing interval because there's nothing underneath your x-axis. So we don't even have to worry about that. You just put NA. And then for range, you're looking at your y value. So for y, we're looking at your y-axis. So it starts at 0 and then it goes up. So we would put closed to infinity because it goes up to infinity. Now, there's some key points here, and you want to look for your perfect squares because you want a perfect square under your radical. And so if we put 1 here, so we get 1. So we're going to use our perfect squares of 1, 4, 9. And you're going to get the points 1, 1, 4, 2, 9, 3. So those are your key points, and you can shift or reflect based off of those. All right, now we're going to talk about cube root functions. So you can think of this one as if you were to take this part of your parabola and then bend it down this way. So if we were to continue this up here, it would look like that, but since it's a cube root, we're now going to have it flip and go that direction. So again, I'm substituting in these values for x, and I've already given you these, and I plotted your points for it. And I did extend it to 8 just so down here, so that's where that is. So if you think about it, it's like you were to take a parabola, slice it in half, and then flip the other side. So that's your cube root function, or sorry, cube function. And then now the cube root function is very similar, except for now we're going this direction instead of this direction. So because we're taking the root, just like your square root, see how we rotated it that direction? So now we're just taking our cube root and rotating it this direction. Now, it's okay to have negatives under a cube root, so these we can all graph because it is okay to have a negative under a cube root. So that's some things to notice. Now, some characteristics of a cube root graph. This is the parent function, y equals a cube root of x, and your starting point is your anchor point, and that's going to be at 0, 0. Now here it does go both directions, so again we're going to go through and we're going to look kind of like what we did up here. So we got our x's, so basically everything has to do with your x except for your range. So we've got x, 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 and then y for your range. So let's look at our increasing intervals. Well, it's increasing this direction and this direction. So we did negative infinity to positive infinity. Now for the decreasing intervals, we don't really have the decreasing part because it's still going directions there. So let's, oh yeah, there it goes. And then so let's look at the domain. So the domain, again, you've got your x, and it's basically going from negative infinity to positive infinity. All right, and then your range, again, since this is going to get wider, that's a horrible graph, but if we were to continue this on, your y's are going to go up and it's going to go down, so that's why you have that. And then the key points here, you're going to look for your perfect cubes. So if we take 1 cubed, we get 1, or take the cube root of 1, excuse me, we get 1. Take the cube root of 8, we get 2. Cube root of 27, you'll get 3. So look for your perfect cubes, and those will be your key points to help you when you're plotting. All right, now let's get started. This should look really familiar. And there's just some slight changes when you're graphing, but everything is pretty similar to what you've done before. Now, in this case, instead of x minus h being in parentheses squared, we don't have that. We now have the square root. K is still outside doing its own thing. A is still in front of the radical. Instead of the parentheses, it's in front of the radical. And then if it's negative, it's a reflection. So if we were to have negative a, it would reflect. If a is greater than 1, it's going to stretch or narrow. So remember, it's going to get more steep. And if it's between 0 and 1, it's going to get less steep and it's going to compress or widen. Now h is still the same as before because it's always going to be x minus whatever the value of h is. So remember, think about it, whatever's under the radical, just do the opposite sign of h. So if you see x minus h, you're shifting right. If you see x plus h, it's really minus a negative h, so you're going to shift left. So same thing as we've done before, it's just under a radical now. And then k is positive, these are exactly the same. It shifts up, if it's negative it goes down. Now instead of the vertex, we don't call it the vertex, we call it the anchor point or your starting point, and that's HK. But it's the same thing, different name, or same idea, different name. All right, so we're going to do this first one just to kind of look at the information. So anytime you have a change from y, so anytime you have a change from that, that is going to be a transformation of whatever. So in this case, we have plus 2. So remember, it's actually a minus 2 because h is the opposite sign. And then negative 3 is outside the radical, so that's your k. So this is your anchor point right here. So now let's look here. A equals 1, so there's no reflection, but h is negative 2, so that means you're going left 2. K is down 3. And then your domain, you're going to look here at your domain, and that's going to go right there. So this is it's going to start at -2, but it's going to go to infinity. In range, you're going to use your k value, and it's going to start from -3 and then go up. All right, and then for this one, we're thinking about our parent function of y equals the cube root of x. So if there's any change from there, it's considered a transformation. So if we notice, a is 1, but it's negative. So that negative means it's reflected. And then there's nothing under the radical, so h is going to be 0. And then k is outside the radical, so that means you're going down 3. So again, use this for your domain, which is your x, and did I write that? Oh, yes, I did. Okay, sorry. Oh, it's cube root. Sorry. I confused myself for a second. So, but anyways, domain, you're here. So remember, domain for the cube root is because you're going this way, but since it's reflected, you're going to actually go that way. So we are right here, but we're going to reflect and go the other direction. So domain and range. All right. So domain, negative infinity, positive infinity, because it's going from here to here. And then range, it's going to get wider as we go. So that's why it's negative infinity, positive infinity. All right, what I want you to do is I want you to try those two. And now we're going to practice graphing. So for this one, you have to be able to figure out what's happening first. So A is 1. So that's going to help us when we enter in our points. Our anchor point is 3, 0. So that's where we're going to begin. Our domain for your square roots goes from 3 to infinity. And your range goes from 0 to infinity. Now, here's the tricky part, is figuring out what to plot. So the goal is you want to try to get perfect square. So get the radical to be a perfect square. So if we were to have, let me go down here where I got a little bit more room. So it's x minus 3 under the radical. So we want to figure out, what do we need to get to be a perfect square? Well, the first perfect square we're going to look at would be 0, which is your anchor point. So 0 is your anchor point. And then the next one would be, okay, so if we've got 1, what do we need to put under the radical to get 1? So if we add 3 to this side, we're going to get x equals 4. So if we make x 4, we're going to get 1. So that's where you put that, okay? So notice your anchor point is the first one, where it's 0. And then our next perfect square, we want to get to 4. So we have to think, what minus 3 equals 4? So remember, if you add 3 to this side, you're going to get 7. So if we make x 7, that's going to give us 4. So that's just one of the tricks to help you whenever you're graphing, to help you get a perfect square under the radical. And then once you get that, then you just go ahead and solve the rest. All right, so now that we have that, let's plot our points. 3, 7, 4, 1, and then, oops. Yep, up 2. Okay, so now go ahead, this is your anchor point, and then make sure you show an arrow off to the side because it is continuing on. All right, I'm going to move this under here just so that way it goes with the information. All right, so now let's go ahead. I want you to try, I want you to try this one. So remember, this one is actually going to be pretty easy because if you notice, it's already x under. So you can just make this, and remember your anchor point is going to be one of the points. So think of your perfect squares. You got 0, 1, 4, 9. So you can continue this on. So this is what your x you would put in here. So go ahead, finish that, and I want you to do the domain and range. And this for number 3, I wanted to do this with you because there's a slight difference to it. If you notice, you've got a negative here. So a is -1. So you got to be careful because we're going to reflect it. But we do know our anchor point is where we're beginning. So that's going to be your first point on your table, and that's your first perfect square, which is 0. All right, so your second perfect square is 1. So we need to think, what do I need to get to be 1, which is a perfect square? So in that case, when you make x 0, you'll get 1, the square root of 1. So then do square root of 1 times -1 minus 2, you get -3. And then here we need to think, what do I need to put for x to get this part to equal 4? So if we were to put 3 here, 3 plus 1 is 4. And then once you put 3 in here, you're going to get square root of 4 times -1 minus 2. So that's going to be -1 times 2 minus 2. And then you'll get -2, minus 2, which gives you -4. So just be careful for that. All right, and then now let's go ahead. I forgot to do domain and range. So domain, we're going to go ahead and we're going to look. And this goes from -1 to infinity. Now, I want you to pay attention. Since this is reflected, watch out for the order. So usually we would put -2 to infinity. But if you notice, these switched spots. So it's actually going to come up, and when I graph it, I'll show you what I mean. But this is going to be a different order than what we did it before. So let's plot, and then we'll go back. So now if you notice, aren't I coming up from -infinity? And it's stopping at -2. So that's why your range, you want to be careful. You got to watch out for the order because it's coming up from -infinity and stopping at 2. So again, when you plot your points, and then go ahead, connect, and draw your arrow. So this reflected from where it should have been. Otherwise, it would have been up here if it were regular. All right. I want you're going to do this one, but make sure you watch this one first. Okay, now we're doing a cube root. So we want to use perfect cubes under the radical. So in this case, it's just x. So we can use, right? And you can do cube root of -8, which equals -2. So I've got -2 times -2 plus 1. So that's where we get 5. All right, so go ahead, and I entered these all in for x. I made this 0, and I got -2 times 0 plus 1. And then make this 1, make this 8. So it's -2 times 2 plus 1. And go ahead and use your points. All right, so now let's look at your domain and range for your cube roots. It's going to be your -infinity to positive infinity for both. All right, so now when we graph it, if you noticed on the original parent function, it went like this. But that's because a was positive. So now if we go back here and we look, since a is negative, and it's a -2, so it's going to be a little bit further apart, if you notice, it went a different direction instead of how we went here. All right, so go ahead, plot your points, and you notice those points are a little more spread out because A is 2 and it's flipped. All right, that was a lot of information, but a lot of it does build off stuff that we've done before with vertex form and parabolas. So that is graphing your square root and your cube root functions.